All right, so we can find these indefinite integrals or some functions in more than one way. For example, with this one, what we could do is we could do use substitution. We could say, okay, well, that's, you know, u equals 1 plus x squared, and then du equals 2x dx. Then we have to make 1/2 times the du to make it work, and we can do that. Another way is we could just multiply. We could square this out and then multiply by x. And when we do that, we get this. And then that's easy to do. That's just going to be x squared over 2 and just continue on. So that one's a pretty easy way. Oops. But this way is not too hard either now that we know how to do use substitution. And so each way, basically, we can easily calculate that antiderivative. And so whatever's easiest for you is what you're going to do in those cases. Now, there's some functions which substitution is not an effective approach, and that's going to be something like e to the x squared or ln of x. So those, it's not really going to help us doing substitution. So we won't be doing substitution in problems like that. Now, two reminders. A variable cannot be moved across the integral sign. So remember, if we had what was it, oop, e to the some power, and then we had like a x here or something like that, and we needed a 3x, well, then we multiplied by 3 here, and then we put it 1/3 out here, and then was able to solve it. But if we had e to some power and we didn't have an x here, we can't say, oh, we're going to multiply by x here and put a 1 over x here. That doesn't work. So the variables cannot be moved out here. Constants can be. And when we're doing integrals, it must be expressed entirely in terms of u and du before applying integrations. Okay, so you can't have it partly in terms of u and partly in terms of x or anything else. It has to be all u and du if you've done substitution. And again, if you wanted to do y and dy or whatever, but usually you say u and du when you're doing it. And so if it has something like that, you can't do it. But if it's the same u, du, or y, dy, then you can do that if you substitute it in that manner. All right, so let's do one last example here. So it says the marginal price, P prime of X, at a supply level of X tubes per week for a certain brand of toothpaste is given by this equation. So what do we have? We find the price supply equation if the supplier is willing to supply 100 tubes per week at a price of 365 each. How many tubes would the supplier be willing to supply at a price of 398 each? All right, so first things first. Let's do substitution here. So I'm going to say, okay, well, let's let that be used. So first off, let u equal 0.01x. du then is 0.01 dx. Now, what do we have? We have 0.001. This says it's only 0.01. So we have to divide this one by 10 or multiply by 1/10 to be able to get to this piece here. So we have to multiply that by 1/10 and that by 1/10. Because remember, what they want us to find is the price supply. So they want us to find what P of X is. Well, to find P of X, we're going to integrate both sides here. And so that's the key here. And again, that's going to be dx and dx's, but I'm just trying to remind you that this is what we're looking for eventually is the px. And so that's why we're doing what we're doing. All right, so with that said, then we say, okay, well, let's just worry about the right side because when I take this in indefinite integral, I know I'm going to get p of x. But what am I going to get on the other side? Well, I'm going to get 1/10 times, and then I'm going to have e to the u, and then it's going to be just du because I've multiplied by that 1/10. So that's going to be 0.001 dx. That's what I have here, 0.001, and there's a dx there. And so now what? Well, now I find that indefinite integral. So that's going to be 1/10 e to the u plus c. Now I go ahead and back substitute that in here. So I get 1/10 e to the 0.01 x plus c. So that then is my p of x. So that's what I have up here. And so that's what I would be looking at. Now they've said, okay, well, if we get 100 tubes for a price of 365, we need to now find C. Okay, so to do that, we're going to say, well, 3.65 equals 1/10 e to the 0.01 times 100 plus C. So now we're going to take all this to the other side and we'll subtract it over here. And what we find out is C is equal to, it's since this is in dollars, 3.38. Okay. And so that means our original P of X equation then is going to be P of X equals 1/10 e to the 0.01x plus 3.38. Okay. So that's my original equation after taking and doing the indefinite integral on it. And that is solving for P or C rather. Now, how many tubes would the supplier be willing to supply at a price of 3.98? Well, now, okay, well now the price is 3.98 and that equals 1/10 e to the 0.01x plus 3.38. So let's subtract off 338. So it's at 0.60 is 1/10 e to the 0.01x and multiply that by 10, multiply that by 10. So 6 equals e to the 0.01x. Now I need that down. So if I take the ln of that, the ln of that, that comes down in front here. And so it looks like if I divide by zero point zero 0.01, divide that by zero point zero 0.01, X is going to be what that is. ln of 6 divided by zero point zero 0.01. Well, that turns out to be 179.17 or approximately 179 tubes per week is what they're willing to supply at a price of $3.98 each. Okay. All right, so hopefully that gives you a kind of a brief understanding of, how we are going to do U-du substitution and different kinds of problems, what we might see. Again, sometimes we have to solve for that C, sometimes we don't. And so it all depends on how the problem is set up. So hopefully that helps you with the 12.2.